You are sitting in a Tier 1 technical interview. The clock is ticking, and you are handed an array containing 1 million distinct elements. Your task is to process that data to find a specific pair matching a condition. Your first instinct is to write a nested loop. You want to take the first element and check it against the remaining 999,999 items. Then move to the second element and repeat the process, comparing every possible combination. This chart shows the mechanical reality of that choice. A nested loop creates O of n squared time complexity. Squaring 1 million elements means your code has to execute 1 trillion distinct operations. The system will time out before it ever reaches an answer. Many candidates try to avoid this by memorizing thousands of isolated specific solutions on LeetCode. They hope that by seeing enough individual problems, they can recognize a familiar answer. But high-level interviews aren't a test of memory. They are a test of your ability to recognize structural constraints. Success in these interviews comes from replacing brute force habits with a repeatable pattern recognition framework. The first layer of this framework requires mapping the problem's constraints directly to specific optimizations. You start by identifying the bottleneck. Are you performing repeated data lookups? Hash maps store key value pairs, shifting ON scans to O1 lookups, making exponential time linear. For sorted arrays, 2 pointers move inward, avoiding redundant checks. For continuous ranges, a sliding window shifts across the array, updating only elements entering and leaving. These patterns serve as logical filters. They ensure that your code never even considers mathematically invalid sections of the data, achieving near-instant performance. While individual patterns solve easy problems, medium and hard challenges often introduce a constraint that breaks a single tool. For example, a continuous subarray problem is usually a candidate for a sliding window until the array contains negative numbers. Negative numbers break the sliding window, as expanding it no longer guarantees an increased sum. Instead, you combine patterns. A prefix sum converts the range into a cumulative total. Then, a hash map searches for a complement. Together, they solve it in a single pass. This concept of define what you need, then search for it, is what allows these patterns to reappear in more complex structures. You'll see frequency counting maps reappear to feed data into heaps, or prefix sums being used as the optimization step within dynamic programming to speed up range calculations. Senior-level problem solving is the ability to recognize where a single pattern lacks coverage and knowing which secondary tool fills that gap. To apply this consistently, you need a protocol for the first 5 minutes of the interview. The goal is to spend 60 seconds decoding the problem before writing any code. Read the prompt and immediately ask clarifying questions about the data. Are there duplicates? Can values be negative? These answers are what confirm which patterns are actually viable. Always state the brute force approach first. Explaining that a naive search will take O of n squared time proves you understand the bottleneck and creates a baseline for the optimization you are about to propose. Then, run through your initial mental checklist. Is the data sorted? If yes, 2 pointers. Is it a continuous range? If yes, sliding window. Does it need fast lookup? If yes, a set or map. Before you code, explicitly state the final time and space complexity. Tell the interviewer, because I am using a hash map here, we reduce the time from squared to linear. This process changes the interview from a guessing game into a structured architectural exercise. When you follow the constraints, the problem itself dictates the optimal code.